Good afternoon, all of you. In the last class, we started our new chapter, Hydrocarbons. We started with a brief introduction on what are hydrocarbon compounds, and then we spoke about the applications, both household application and about the industrial applications of hydrocarbon compounds. Then we came across the classification of hydrocarbon compounds. Hydrocarbon was classified into open chain and closed chain. Closed chain means the cyclic ones and open chain means long chains. Then they were further classified into four different categories according to their properties shown and about the structure. All those things we told. And out of this classification, we spoke about the first classification, saturated alkanes. So alkanes, we studied what are alkanes and how to calculate the number of hydrogen atoms from the number of carbon atoms given. Till there we spoke yesterday. Today we are moving on to the next topic, which is nomenclature and isomerism. So in this we will speak about isomerism now. First three alkanes, methane, ethane and propane, have only one structure, but higher alkanes can have more than one structure. Yesterday we have seen the structures of methane, ethane and propane, the one with one carbon, two carbons and with three carbons. So they are actually very simple structures. But the higher alkanes are not like that. They will have more and more complex structures and not even one structure. We can represent them with different structures. For example, we are taking C4H10, which is with the 4 carbons, which is butane. So 4 carbon atoms of a C4H10 can be joined either in a continuous chain or with a branched chain. We will see how it is done. So C4H10, the butane, first structure will be like this. So in the straight chain, the normal butane is written in a straight chain. The C1, C2, C3 and C4 written in straight chain, and if you consider hydrogen 10, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So the formula is correct here and it is in a chain form, straight chain format and with the boiling point of 273 Kelvin. And the next compound, if we see, it is like this. So there also you can see 4 carbons C4 and H10 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So the formula is correct here also. Both the cases you can see the same formula but different type of structures. So here it is done in a straight chain but here it is done in a branched chain we tell. Here we consider this as the straight chain, the longest one as the straight chain, another as a branch. So here one of the hydrogen is substituted with the CH3 group from here. From here one CH3 is taken and substituted here and there that hydrogen will go there. So that is the change happened here. But still the formula is same. So this kind of structures where the formula will be same, but if you see the boiling point, it is 261. Boiling point also changed there. So change in properties are there, change in structure is also there, but there is no change in the formula. So this kind of systems we tell they are showing isomerism. So this property of showing different type of properties with the same molecular formula we tell they are showing isomerism. So structure 1 and structure 2 possess the same molecular formula but they differ in their boiling points, even in other properties. So this nature of hydrocarbons to show same molecular formula but different properties according to their structural difference is known as isomerism. So another compound we are considering here, C5H12, which is pentane. So the first structure is this N-pentane, the normal pentane with the straight chain. If you see there are 5 carbons and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. 12 hydrogens are also there. So the same structure you can write in a different way like this. So if you write it in a different way, it becomes another compound only. So this is 2-methyl butane with boiling point of 301 Kelvin. Boiling point also changed there and other properties also. So if you see here, here also you can see 1, 2, 3, 4, 4 carbons in the straight chain and one of them substituted in the second carbon with a branched chain. So this structure will show different nature or properties than this one. So both of them are having same molecular formula but different properties, and that property is known as isomerism. As they are showing difference in the structure, they are known as structural isomers, or the isomerism is due to the structural change. And one more particular thing we can tell, which is the structure is in the difference of chain. So chain structure is different here. Once it is a long chain, once it is a branched chain. And that's why we can call them chain isomers also. So structural isomers which differ in their chain of carbon atoms are known as chain isomers. So this are having difference in their chain, and even the last example which we discussed, this are also having difference in their chain structure. One is long chain and one is branched. So both of them we can tell they are chain isomers or chain structural isomers. Just now we have seen the two isomers of C5H12, but C6H14 when it comes it will get 5 isomers. So the 5 isomers are shown here and you don't need to write it in your notebook. I am just showing it as a reference. So N-hexane, the normal hexane with the straight chain will be like this. And one of the carbon when it comes to branched, it will get another structure like this. So 2-methyl pentane. In the second carbon, the branched CH3 is substituted. So this structure is different from this structure and this will have different property. And this carbon changed its position to 3. So third carbon when it comes to substitution, then the properties will change entirely. Like this, the change in structure is happening. And in this case if you see, 2 carbon atoms got substituted here. Here also you can see both 2 carbons but with the changed position. So like this, there are more and more isomers formed when the carbon atom increases. So as the carbon atom increases, it will get more and more of isomers as they have availability of different structure types. So C6H14 or the hexane has got 5 isomers, but C7H16 when one carbon increases it will get 9 isomers. So when it reaches C10H22 or the decane there are 75 isomers possible. So those 75 will have different properties also. And this is the fun of isomerism. And this is also the importance of structures in organic chemistry. Because when we know just about the molecular formula, we cannot tell which structure it is showing. It will be showing different isomers. So we need to specify the structure also. Now we will see another facts related to the hydrocarbon compounds. Based upon the number of carbon atoms attached to a carbon atom, the carbon atoms are termed as primary, secondary, tertiary or quaternary. We will see what it is. So carbon atom attached to no other carbon atom as in methane or to only one carbon atom as in ethane, it is called primary carbon atom. And terminal carbon atoms or carbon atoms in both the sides are always primary. We will see all examples for this. So carbon atom attached to two carbon atoms is known as secondary carbon, and tertiary carbon is attached to 3 carbon and quaternary attached to 4 carbons. So once you see the examples of this, you will get a better idea. So first example is given here, and consider just this carbon. So this carbon we need to see with how many carbons this one is attached. So hydrogen is attached, another hydrogen, this is also hydrogen, but here it is attached to a carbon. So one carbon is attached to this. So we can tell this particular carbon is a primary carbon. As it is attached to just one carbon, we need to tell it's a primary carbon. So if you consider this carbon, how many carbons are attached to this? To this one and to this one. So 2 carbon atoms are attached to this carbon. So we can tell it's a secondary carbon because they are attached to 2 other carbon atoms. And this one also is attached to just one carbon. So we can tell it's a primary carbon. And what one more point what we told is that terminal carbons are always primary. So the end carbons in both ends, if you see, both are attached to just one carbon. So terminal carbons are always, in most of the cases, they are primary. So another example given here. So with this carbon, there are two carbons attached. So we can tell this one is a secondary carbon. We have told example here also. And these two are primary as they are attached to just one carbon. So if you consider this carbon, there are three carbons attached to it. This one carbon, this is the second carbon, and this is the third one. So three carbon atoms are attached with this particular carbon. So this carbon in the red color is a tertiary carbon. And this one with four carbons attached to them, they are quaternary carbons. And all the others are primary carbons here because all of them are attached to just one carbon. We are just seeing the direct attachment. If you see here, this carbon is attached to another one, so we cannot calculate that. We are just considering the direct attachment with other carbon. So we will see few other examples also. So in this case, this carbon, just now what we have seen the example the same only, the four carbons are attached with the one single carbon, and this carbon is a quaternary one and all others are primary ones. And here if you see, this carbon is a primary carbon and as it is attached to just one carbon atom, and this also is a primary. That's why we tell all terminal carbon atoms are primary. These two are primary and even this one is primary. So this one and this one all are at the end or end position. So end position means they are attached to just one carbon and they are primary carbons. So next carbon atom, this one if you see, this is attached to two other carbons. So it is a secondary carbon. This one also is a secondary carbon as it is attached with or directly attached with two other carbons. So this is secondary carbon. This one if you see 1, 2 and 3 and all of them are attached with carbon only. This bond that is directly showing to hydrogen, but it is actually a bond with carbon only. The two hydrogens are standing like this. So if you write the structure like we did yesterday, we will understand that. So this carbon is attached with three other carbon. So it is a tertiary carbon. This one is also a tertiary carbon. This one is also a tertiary carbon. So we have primary, secondary and tertiary carbons in this figure. So you need to write this figure and mark which one is primary, secondary and tertiary and for this compound also. So this compound, this is how I told, if you write like this, you will understand how the bonding is done. And if you write like this, you will get confused. So this is how the bonding is done in all the places. One carbon is here and two hydrogens will be standing like this. So it is not attached to hydrogen. Carbon and hydrogen is not bonding here. Carbon and carbon is bonding, but hydrogens are bonded with the next carbon only. So this structure if you see, the first and the last carbon, the terminal carbon atoms are primary ones. So if the carbon is not attached with any of other carbons like the methane, then also we will consider it as a primary only. So this and this one is primary. All other three are secondary carbons as all of them are attached with two other carbon atoms. So that's how we represent primary, secondary and tertiary quaternary carbons. You have a work to do now. So out of this, you need to find which one is primary, secondary and quaternary carbons and mark it properly and send it with the notes. So with this, we conclude our session. So please go through the textbook well and prepare notes. Thank you.